Instance methods. You learned how to use instant methods in the instances lesson. When you define your own type, you can also define instance methods. Instance methods are declared like functions, but you put them inside of the body of the type definition. So here we have our struct rectangle, width and height. Function, which is inside of our struct type, is bigger than. So this is the function we made in the last on the last page. So is bigger than, so is rectangle is the only input here, and it returns a bool. So let area 1 get width times height. So this is referencing itself, so its own width and height. Let area 2 get rectangle.width times rectangle.height. So this is whatever rectangle you're comparing it to. And then it returns, is area 1 bigger than area 2? So it only needs this one parameter because it is referencing itself here. You are only comparing itself, which is going to be, when you call it, the first variable that you use, and then dot, and then it's going to be the other rectangle. So is dot is bigger than is the other rectangle you're calling in the parentheses. Notice that within the body of the method definition, you can access the values of height and width of the struct without using a dot. The instance method is written as part of the struct definition, and so it can directly access the properties with the instance. So that just means this width and height, like I said, is part of this, so you don't need the dot notation. Just like the methods on built-in types, the methods you define are called using the instance name, then a dot, then the name and arguments of the method, so like this. So let rectangle get the type rectangle with a width of 10 and a height of 10. Let other rectangle get the type of rectangle, width of 10, height of 20. So then we are looking at this rectangle, dot is bigger than, so we were running this method, which again works like a function, and we are comparing it to the other rectangle. So this rectangle is not bigger than this other rectangle, so this is false. And then we flip it, other rectangle is bigger than rectangle. This is true because it's flipped the other direction. Exercise. Simplify the is bigger than method by creating a compound property named area for the rectangle struct, and then using the computed property inside of the is bigger than method. So we are going to come back up here. Make a variable area, which is an integer. And we are going to return width times height. And then after that, we are going to reference area. So is this rectangle's area bigger than the area of the rectangle that we are passing into the function, so into the method. So again, is this rectangle's area, notice I don't need the dot notation here, bigger than the rectangle that I'm comparing to, so whatever rectangle I use in my method, dot area, so its area. And next. For further practice, extend the song struct below by adding a is longer than method. You can paste your code from page 6 as a starting point, then use a loop to find the longest song in the array and print it to the console. Hint, use a variable to keep track of the longest song and initialize it to the first one in the array. So we have our song struct here, and then code from page 6 here plus the new method. So we are going to go with formatted duration, and and title and information. So pasting all of that work there. Then we are going to add a functionality. So a method is longer than, and let's say the other song. So other is the parameter name, but we don't need to see it. So it's is this longer than, and then whatever the song is going to appear here without the argument label. So that's, again, what this underscore does. It just omits this label from when you call the method. But it is of the type song. And then we need our curly brackets. Oh, we are going to return a bool. So is this going to be true or false? So then return duration greater than other duration. So we're just looking at this song's duration. Is that greater than another song's duration, whatever song we pass into the method? All right, and then we're going to use a loop to find the longest song in the array and print it to the console. So we're going to use a variable to keep track of the longest song and initialize it to the first one in the array. So we have our songs. We're going to make a variable to find our longest song, and we are going to initialize it to the first item in the array, which is of the index of 0. That is going to give us a starting point to compare every other song to. So if this is the shortest song in the array, it'll get replaced immediately, but the longest song is going to be in the array somewhere, and we have to start with the first one so that we have something to compare to. So the first time through this loop, it's going to compare to itself, so it's not going to change, but that's okay. So for each song in songs, we are going to, if longest song, if song, so we're using our method here. So if the current song we are using is longer than, we're going to have to compare it to our stored variable, the longest song. Then we are going to replace longest song with our current song. If this is not true, the longest song stays with whatever it currently is on that iteration through the loop. So now we are going to print, so we're going to test this. The longest song is whatever the longest song is, dot information, because we want all of that information. We will give this a moment. But it should come out with, this is just Xcode and our RAM not working very well. Make sure that we don't have any, oh. All right, we did make an error up here. Area should be declared before the function because we use area within the function. So make sure that you have all of your variables and constants above this. Otherwise, it won't work. And this is still not calculating. But this part is right, so we're going to move on. Instance methods are just like computed properties in the way that they enable data abstraction. Next, a summary of what you've learned.